Hello friends, in this video let us discuss about the constructional details of your three-phase induction motor. So any electrical motor is defined as an electromechanical device which converts the energy in electrical domain to mechanical energy. So among the three-phase operations, the most widely used motor is your three-phase induction motor because almost 80% of the power, that is the mechanical power used by the industries, is provided by your three-phase induction motor because of various reasons like simple and rugged construction, you can say low cost, and we do not need any external prime mover to start your motor. So it is a self-starting motor and it has good operating characteristics, and it has good speed regulation, and absence of commutator and brushes makes it maintenance free. So for various reasons these three-phase induction motors are widely employed in our industries. Now for any rotational electrical motor, it has mainly two parts. So the first part is stator and the second part is rotor. Now apart from these two parts, we can also have a shaft to transmit the torque to the load, and we can also have bearings to support this rotational shaft, and we can also have a terminal box to provide electrical connection. So terminal box, and one of the problem associated with these machines are overheating, so we need fans for cooling these type of motors. So apart from stator and rotor, you are having shaft and bearings, terminal box and fan. So now let us discuss the stator and rotor effectively here. So if you look at the overall construction of your three-phase induction motor, so this represents your core, and here are your windings, and these are stators. This is frame. The frame is the outer cover. This is your frame, and here your stator core, and these are your windings wound on your stator core or stator slots. So here this represents your rotor, and these are the conductors, and this is the shaft, which is the rotor is connected to the mechanical load through this shaft, and you are having rotor conductors. So now actually the stator has mainly three parts. So defining stator, the name itself suggests is a stationary part of the three-phase induction motor. The stator core carries your three-phase windings to which the three-phase AC supply is given, and the windings are arranged in such a way that a rotational magnetic field is produced. So the stator has three parts. One is stator core, the first thing is stator frame coming from outside. So the frame is the outermost covering of your three-phase induction motor, and the other is stator core, which is inside the stator frame, and the other one is you are having stator winding or field winding. So discussing about the stator frame, it is the outermost cover of your three-phase induction motor. Its main function is to support the stator core and the stator windings. So it also helps to provide protection and mechanical strength to all the inner parts of your three-phase induction motor. So the stator frame is generally made up of die-cast or fabricated steel. So the main requirement for your stator frame is it must be very strong and rigid, as because of the air gap length, that is the distance between the rotor and stator, is very less, that is 0.4 mm to 4 mm. So as the distance between the rotor and the stator is very less, the frame has to be very strong and rigid, otherwise your rotor may not remain concentric with your stator part, and it may give rise to unbalanced magnetic pull to your rotor. So hence your stator frame must be very strong and rigid. Now coming to the stator core, the stator core carries alternating flux. The stator core is made up of number of laminations. In order to reduce the eddy current losses, the stator core is made up of laminations, and these laminations are the type of structures made up of stampings which are about thickness of 0.4 to 0.5 mm, and these stampings are stamped together to form your stator core, which is going to be housed in your stator frame. And the stator core is generally made up of the material that is CRGO silicon steel, that is cold rolled grain oriented silicon steel, in order to reduce the hysteresis losses occurring in your 3-phase induction motor. Now coming to the stator winding or field winding, the slots on the periphery of your stator core carries 3-phase windings, that is R, Y, B, and these 3-phase windings can be provided with 3-phase supply, and if the windings are arranged in such a way, they can produce a rotating magnetic field. Now the 3-phase windings can be either star or delta connected depending on the type of starter used for your 3-phase induction motor. For squirrel cage type of induction motor, mostly star delta type of starter is used for starting the motor, and hence the stator for your squirrel cage type of induction motor is delta connected, and for slip ring type of induction motor, the starting can be done by inserting external resistances, and hence the stator can be either star or delta connected. And when the 3-phase AC supply is provided to the 3-phase AC 3-phase windings, that is R, Y, and B, then if the windings are balanced, that is the spatial distribution of windings is arranged, then if the balanced 3-phase supply is given, a rotating magnetic field is produced, and this rotating magnetic field sweeps over your rotor conductors. And if the rotor conductors are short circuited, or you can say initially the rotor is at standstill, and at the standstill the rotor conductors are stationary, and the RMF sweeps over your rotor conductors and it induces a EMF according to Faraday's law, that is minus d phi by dt, where you are having change in the magnetic flux over the stationary conductors, and this induced EMF, as the rotor conductors are short circuited, this induced EMF circulates current in your rotor conductors, and this rotor conductor introduces its own flux known as rotor flux, and this rotor flux interacts with your stator flux, and a mechanical force is being exerted in your rotor, and hence the torque start developing, and hence your motor starts rotating. This is the working principle. We are discussing the construction of 3-phase induction motor only. So here you are giving 3-phase AC supply to your 3-phase windings. Now this is about your stator winding or field winding. Now coming to the rotor can be further classified into 2 types. So one is the squirrel cage type of rotor, and the other is slip ring or wound rotor or phase wound rotor. You can say any name, slip ring or wound rotor or phase wound rotor. Now depending on the type of rotor being used, you can classify your 3-phase induction motor into 2 types. One is squirrel cage type of induction motor, and the other is slip ring type of induction motor. So for both these type of rotors, the stator part remains the same. Either you can use squirrel cage type of rotor or slip ring type of rotor, the stator part is the same, that is having stator frame, stator core, and the stator winding. And now let us discuss these 2 type of rotors by taking their motors. If I take my squirrel cage type of motor, in this type of motors, the squirrel cage type of rotor is in cylindrical shape and have slots on its periphery. So if you see the squirrel cage type of rotor, This is your squirrel cage type of rotor, that is cylindrical in shape, and the slots on the periphery of your rotor are generally arranged in skewed manner. That is skewed, that means they are neither parallel or perpendicular to the axis of rotation of your shaft. So here is your shaft. These are your bearings which support your rotating shaft, and here are your skewed slots on which conductors are fitted. So here you see the bearings which support the shaft, and the slots are parallel to each other and but are skewed with respect to the axis of rotation of shaft. So this is done because to prevent the magnetic teeth locking of your rotor slots and the stator slots, thereby you can reduce the effect, or you can overcome the effect of cogging taking place in your squirrel cage type of induction motor. This also further reduces the magnetic humming noise and avoids stalling. So skewing is done for squirrel cage type of rotors because of the advantages discussed. So skewing is neither parallel or perpendicular to the axis of rotation, but they are slanted with the axis of shaft. So the slots are parallel to each other but are skewed with respect to the shaft. Now the conductors here employed can be aluminium, brass or copper. So these conductors are called as rotor conductors, and these rotor conductors are shorted at the end with the help of end rings. So these are your end rings. The end rings can be copper or aluminium rings. Now as the resistance is very small, you cannot add external resistance, as they are permanently shorted with the help of end rings, and there is no possibility to add external resistance to your squirrel cage type of rotor. And here, in order to provide mechanical strength to the rotor, the rotor conductors are braced to the end rings and form a closed circuit, and this closed circuit represents or resembles like a cage, and hence the name squirrel cage type of rotor. So here we cannot add external resistance as they are permanently shorted with the help of end rings, and the rotor conductors are braced to the end rings to form to provide mechanical strength, and hence they form, when they are braced to the end rings, they form a closed loop circuit, and this resembles like a squirrel cage, and hence the name squirrel cage type of motor. And here we are not employing any commutators or brushes, and this helps helps in the advantage of maintenance free of your squirrel cage type of motor. So if you are employing commutators and brushes, we require a lot of maintenance, and hence your squirrel cage type of rotor we are not using, or we are not employing any type of commutators or brushes. The advantage is maintenance free, and the construction is very simple and rugged. So if you see, it is having the two type of advantages. The one advantage is the construction is very simple and rugged. The other advantage is it is maintenance free because of the absence of commutators and the brushes. So these type of motors or these type of rotors, or you can say squirrel cage type of induction motor, can be used in can be widely used in our industries where maintenance is not required so much, and generally these type of motors are employed in lathe machines, printing machines, fans, blowers, etc. Now we shall discuss about the slip ring type of motor by taking slip ring induction motor. By taking slip ring induction motor, we shall discuss the slip ring rotor or wound rotor or phase wound rotor. Here the rotor is wound for the same number of poles as that of stator, but it has lesser number of slots and less turns of a heavier conductor. So the rotor conductors can be arranged in either star or delta connected, just like of stator windings. So the rotor consists of number of slots in which the rotor windings are placed and the rotor terminals are connected at the end to form a star connection. If I say this is R, Y and B. So the rotor terminals are connected at the ends to form a star connection, and the other terminals of the three windings are permanently connected to your slip rings. So these three are your slip rings. So slip ring is nothing but an electromechanical device which allows the transfer of power or electrical signals from a stationary part to rotating part. So here the three other terminals of the rotor windings are connected to the slip rings, and you can also find here brushes. Here these are your brushes. So these brushes helps you to transfer to and from the rotor power. So power transmission can be done to the rotor and from the rotor through these brushes. Through these brushes, the power transmission can be done to and from the rotor, and externally three resistances are connected to these brushes which are star connected. So the star connected brushes are connected to the rotor resistances or rotor windings through this slip ring and brushes. So when the motor is starting, these resistances are used, and as the rotor picks up its speed, gradually the resistance are cut off, and when the motor is running under running condition, then the three slip rings are shorted with the help of metal collar. With the help of metal collar, all the three slip rings are connected together, and the brushes are also removed when the motor is in running condition. So this reduces the wear and tear of your brushes during the running condition, and as we are employing the slip rings and the brushes here, the construction is little complicated compared to your squirrel cage type of induction motor, and these external resistances which are star connected here helps us in reducing the initial current, or you can say starting current. That's why they are employed in the starting of your slip ring type of induction motor. So generally the starting of your slip ring type of induction motor is done by inserting the external resistances, because this reduces the starting current, and you can also have the high starting torque in your squirrel cage, in your slip ring type of induction motor, and you can have the good speed regulation by changing the resistances here. So you can have speed regulation and high starting torque in your slip ring type of induction motor. So generally you can see the advantage of slip ring induction motor is high starting torque and low starting current, and there is a good possibility of speed control in your slip ring type of induction motor compared to your squirrel cage type of induction motor. So initially when the starting of motor, the external resistances are connected to the rotor windings through slip ring and brushes. The brushes are used for transferring power to and from the rotor, and the slip rings here are used just for allowing the external resistances to connected to the brushes. So the slip rings are normally used in electromechanical device which continues its rotation while transferring the electrical and power signals. So the rotation is to be maintained in the rotor, but you have to connect these external resistances to the rotor windings only with the help of slip rings and the brushes. So the construction is little complicated as you compare to the squirrel cage type of rotor, but the advantage we are having is high starting torque, and there is a good possibility in speed regulation, and hence the application of this, what we say, slip ring type of induction motor can be seen in hoist, cranes and elevators, etc. So this is the overall conception of your 3-phase induction motor. We have successfully studied what is the stator and the 3 main parts of the stator, that is frame, core and the stator winding, and we have successfully studied the rotor. Rotor is further classified into 2 types, that is the squirrel cage and the slip ring type of rotor. This is your squirrel cage type of rotor, which is permanently short circuited at the ends with the help of end rings, and we have seen the bearings which support the rotational shaft, and the rotor is connected to the mechanical load through this shaft, and we have successfully also seen the slip ring type of induction motor. So here this is your shaft. As the name suggests, slip ring type of induction motor, the slip rings are connected to the shaft as same as that of rotor. So here is your shaft, and this shaft is connected to the mechanical load. So the rotor is connected to the mechanical load to the shaft, and we are using slip rings and brushes for the external resistances to be connected to the rotor winding, which helps in reducing the starting current and increasing the starting torque, and these resistances, externally connected resistances, also helps in the good possibility of speed regulation. And once the motor has started, the 3 slip rings are connected together with the help of metal collar, and the brushes can be removed, and this reduces the wear and tear of your brushes. And but using these slip rings and brushes make it little complicated than your squirrel cage type of induction motor. So this is all about the conception of your 3-phase induction motor. I hope you have understood well. Please subscribe to the channel. Thank you.